Chemistry, example 4, rate of a reaction. A chemical reaction results in the formation of one or more substances called products from one or more starting materials called reactants. So for instance, the following equation, 2 times H2 plus O2 is equal to 2 times H2O, indicates that 2 molecules of hydrogen and 1 molecule of oxygen form 2 molecules of water. Let's consider the reaction. A plus B gives you C, where A and B are the reactants and C is the product. Now, the concentration of a reactant A is the number of moles. 1 mole is equal to 6.022 times 10 to the 23 molecules per liter and is denoted by A with brackets. Now, the concentration varies during a reaction, so A, B, and C are all functions of time, t. The average rate of reaction of the product C over a time interval is where t is in between t1 and t2 inclusive. Now, the change in C over the change in t is equal to the following. We have C of T2 minus C of T1 divided by T2 minus T1. But chemists are more interested in the instantaneous rate of reaction, which is obtained by taking the limit of the average rate of reaction as the time interval change of T approaches 0. So the rate of reaction is equal to the limit as the change of T approaches 0, which is the change of C over the change of T, which is equal to the derivative of C with respect to T. Now, since the concentration of the product increases as the reaction proceeds, the derivative d of C divided by d of T will be positive, and so the rate of reaction of C is positive. Now, the concentrations of the reactants, however, decrease during the reaction. So to make the rates of reaction A and B positive numbers, we put minus signs in front of the derivatives d of A divided by dt and d of B divided by dt, since A and B each decrease at the same rate that C increases. So we have the rate of reaction is equal to d of C over dt is equal to negative d of A over dt, which is equal to negative d of B over dt. And so more generally, it turns out that for a reaction of the form lowercase a times capital A plus b, lowercase b times capital B gives us lowercase c times capital C plus lowercase d times capital D. And what we get is negative 1 over A times the derivative of A with respect to t, which is equal to negative 1 over B times the derivative of B with respect to t, which is equal to positive 1 over C times derivative with respect to C over dt, which is equal to 1 over d times the derivative of d with respect to t. Now, the rate of a reaction can be determined from data in graphical methods. In some cases, there are explicit formulas for the concentrations as functions of time, which enable us to compute the rate of reaction.